Hi everyone, welcome to day one of our Array and String Master series for placements at Aarush Coaching Classes. If you are new here, please subscribe to our channel for data structure data content. Okay, and today we are gonna master the basics of array and then the memory mapping and how to work upon it. Hi everyone, I am Akshay and I welcome you all future coding champions for whom I am thrilled to begin our placement accelerator series for arrays and strings mastery. Okay, and over the next 30 days, we are going to transform how you think about coding problems. Okay, so let's begin. But before moving forward, let me ask you something. Okay, the question is gonna be uh, have you ever tried to manage 100 different grocery lists on 100 different pieces of paper? Okay, like 100 grocery list, 100 lists. It will become very chaotic, right? Chaotic in what way? If you want to find an item or search for any single item in the list, which is all the categories of items like dairy, okay, all items like dairy, then there's a bread, then there is the spices, etc. So let's say if L1 is the list, L2 is the list, L3 is the list, and these lists have items from dairy. Let's say it have the milk, list 2 have the cheese, list 3 have the butter. Okay, this have white bread, this have cardamom from the spices. Okay, this has cinnamon from the spices, and this have the brown bread. Okay, this have the garlic bread. Okay, then this have something more like the uh, I mean, just take anything like some beverages are also there in dairy. What else you can write as from the bread? Let's say some bun is also there. Okay, so if the list is very big and let's say you want to find something. Okay, you just want to find something on the spices. You would have to go through all the list till 100. And but if you find that is okay, otherwise you would have to find till the list number 100. You won't know where to look at. Okay, completely chaotic. But but what if you had one organized notebook where each page represents a category? Like page one represents dairy. Page 2 represents spices. Page 3 represents bread. Okay. So, and so on. Okay. Page 4, page 5, whatever pages are there. Means total number of categories is what the page would be having. Okay. So, like I can say, no, what the pen is not working properly. Let's say for this dairy, uh, we will have the milk, cheese, butter, the spices, cardamom, cinnamon, okay. And here we can say simply bun, white bread, brown bread, garlic bread. So this way, if you want to look for spices, you can just go to page which have spice and then just check. Okay, what are the items? Okay. So it is more like every page is a collection of now every page is a collection of what? Every page is a collection of items of same category. So this kind of structure makes things efficient. And this is somewhat related to arrays. Array is nothing but collection of items of same kind. Collections of item of same kind or category, you can see. What I have written here, that's what an array. In short, in very basic language, you can say. So the most fundamental way to bring structure to your data is what array brings. Okay. So let's move forward towards today's journey. Okay, what we are gonna cover. So we will be covering today the data types. Okay, primitive and non-primitive ones. Okay, because we are going to building from the ground up. Uh, what arrays of made of? Okay, this would be that, and then how they live in the memory. So memory model and addressing would also be discussed here, and then end with the problem solving thing on 1D, 2D array both. Okay, so let's move forward. Let's have a quick warm-up question first. So what's the, because I know most of you are here because you know at least something about DSA. You're not completely new. You must have heard about it in your college. You must have been preparing for placements and number of reasons, but at least you have heard about it. Okay. So my question is, what's the most frustrating part about learning DSA for placements for you? What is that? Is it too much theory, not knowing which problems to practice, getting stuck on optimization, or something else? There are multiple challenges. I just want to know what you people actually face. So you can probably write it in the comment and I can see it later. Okay. Take 2 seconds and please put it in the comment. Okay. So next, let's move to the things, or as you can say the basics, what arrays is made up of. Okay. So here, though array is a collection of items, okay, but in computer science and data structures, you know that there are data types. Means every data is defined by its type. Okay, some type must be there. Like, so in that way, there are two major data types. First is the primitive one. Second is the non-primitive one. As the name suggests, primitive ones. Okay, these are more like the Lego units. Okay, इनसे नीचे तो कुछ हो नहीं सकता. Lego units of fixed size. Okay, like if the data is of value integer, so it is called as int type. If there's a something, there's some data which have decimal values, so you can term it as double. Okay, that data type would be double. If there's some single character only, then that would be called as char. And if there is only true false type of thing, then that is called as boolean. But as here I told you earlier, Lagrange units of fixed size. So here you can see every integer is of size 4 bytes. Every decimal number or double is of size 8 bytes. Every character is of size 2 bytes. And every boolean is of size 1 bit. This is the space they take in memory. Okay, so these are the primitive data types, Lego units, and there's nothing smaller than these. Okay, to store in data means directly the way used in the data, not on the chip level because chip level is different. They have flip-flops and it goes in the bits, so don't worry about that. But moving further, then there are the non-primitive data types, which are complex structures. Non-primitive data types are nothing but more like you can say pre-built pre-built Lego structures. Okay, pre-built Lego structures. Why we are saying that? Because they are created by using the primitive data types or the Lego units. Like, let's take an example of a string. A string is a non-primitive data type. So a variable name is of type string contains what? Name of some person. Here it is John. John is what? John and N. If you look at the individual level, every component of John is nothing but a what? Character. Character is what? Again, a primitive data type. Yes or no? Okay. And they can grow and change also. Like character can't grow and change. It is gonna take single character of 2 bytes only. But Name, though we said that name is a variable of a string type, here it is written John. Let's say if I want to put something else, if I put my name, Akshay. So here it was four characters, okay? But now how much characters? It is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 characters it is. So that's why they can change, okay? Grow and change. Similarly here, an array. Array is what? We heard about it earlier. Collection of items of same type. Collection of items of same type stored contiguously. Okay. What does it mean? I will tell you later. Don't worry about it. Right now, focus here. Okay. So here, is course is nothing but a variable array which is gonna store integers. Okay. Here, it is not necessary that it can be integer only. It can be string. It can be character. It can be boolean. Anything. Okay. Then next is the object person. Till here, you must have seen that though they are, I mean, complex data structures, but they still store same kind of data. But with objects, there's something special, okay? They are custom objects. What does custom means? Custom means according to the requirement, okay? Like, let's say I want to store the data of a person. So, what a data of person stores like? Name hoga, age, name, age, department ID, if he is working, okay? Salary बोल सकते हैं, okay? But this is all about a person. This is a single, going to be in a single non-primitive data set. Okay. But at the same time, you can just check what are the items that are going to be stored here, or what are the data types. Name is string, age is integer, department ID can be integer string, let's take as string, salary decimal से भी आती है, double. Okay. This all constitutes one item. Okay. Of multiple data types. So that's why it is custom objects, and data type is called object, not a particular specific data type like integer, double, because it can have multiple things. And similarly, the size of this object depends upon what are the components or what are the component data types. Okay. So you would have to add all the values and then you will get what is the actual size of one item of this data type. Okay. So that discussion would be we would be having later when we learn about the linked list. But for now, I think this would be enough to explain this. So what we can see here is, I think it is very clear the difference between primitive and non-primitive data type. Array is a non-primitive data type, okay, which is nothing but collection of primitive data types of same type, okay, yeah, and they can grow. So let's move to the next part. Next is, let's have a quick quiz because we talked about data types and their sizes. So tell me, if an integer takes 4 bytes, then how much memory it will be taking for three variables: a is equals to 10 of a data type, b equals to 20, c equals to 30. Take 2 seconds and then answer in the chat. Okay. Hint would be, here it is also written. So if one integer variable takes 4 bytes, how many variables are there? 1, 2, and 3. So 3 integer variables would take 3 into 4 equals to 12 bytes. So the answer would be what? Answer would be this one. Let's see. Okay, this would be the answer. So let's move quickly to the next part. Yeah, why arrays actually? So though I gave you a little example at the very beginning, but let me now make things very clear in by showing you a bigger picture. Okay, because in computer science we deal with the data. Okay, that's why there is the data structures and algorithms. If you don't know how to store the data in such a way that you can optimize things, means accessing it and working upon it, then there will be an issue. Okay. Like, for example, let's say you want to store daily temperature data, okay, for 7 days. It can be more, but let's take a small example of 7 days. Okay. So for every day, I can take seven variables. Day one, I'm still 25. Day two, I'm still 27. Day three, 32, 17, 19, 20, 25, so on. Okay. Though I have stored, that is completely okay. Though it is a little clumsy, but let's say if it is acceptable. But what if I want to access them and work on them? Access them and work on them. That will be chaotic. Why? Here it is just 7 days. But do you really think that in real life there is only seven data? No. The data is in billions. Okay. So billions of variables you would be creating, billions of variables you would be working with, I mean to access the data. Okay. And then working upon it. That would be very chaotic. सबका नाम ही लिखना पड़ेगा. Even simple printing these will take you to print all the variable names like day one, then day two, and so on. Then only you can do this. So it's even in the common sense way also it is looking very chaotic. But if you can just look at the pattern about this data, not all the data, but about this data. Why? Because I need to focus upon something. Though this is data of 7 day, and though in case it was of billion days also, but what is common here? All the data is of same type, integer, 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 integer. Yes. So what is an array? Array is collection of items of same data type, correct? So we can directly store these data in an array. This way, though the space is gonna be taken same. Okay. So here seven variables are there. So 7 into 4, 28 bytes. This array is also gonna take 7 into 4, 28 bytes. Space में कोई issue नहीं होगा. But the way things are gonna be accessed would become more efficient, and that way we can work upon it in a very efficient way. है ना? Access कर लिया, then इसको modify भी कर सकते हैं, कहीं और use कर सकते हैं. There are too many things that we can get done with. Okay. How this is gonna work, I will show you in the later slides, but at least I'm showing you why array is important. Okay. One more thing that you need to focus upon. Okay. If you take these individual integers, okay, integer type variables, 7 or 10 power 9, or you can say billions of variables, this is the memory. Have a look. This is the memory, and the memory is completely linear. So if you take different variables, let's say temp1 can be stored here, temp2 is suddenly stored here, temp3 is stored somewhere. But how does computer takes the data? It puts chunk of data in the RAM, okay, and that's how you access it quickly, correct? RAM have its own limitations compared to the physical memory, proper memory, correct? So it can, let's say it might just take this chunk. So once you try to access this variable, okay, the system have to go back to the hard disk, bring it there in the RAM again, okay. So there can be some issues, or you can say the latency can be high. But if you put things in the array, so whenever there is an array, though it is a collection of items, but all the items are stored contiguously also. They are all same items of same data types of same category, means collection of items of same category. So 25 would be here, 27 would be here, 32 would be here, 17 would be here, 19 would be here, 22 would be here, 25 would be here. This way, accessing them becomes very easy. All the items are stored contiguously, one after the other. So the whole chunk, or whatever possible chunk, goes into the physical memory, whatever it is capable of. Then the chance of hitting the data on requirement becomes higher compared to this way. Okay, because these are stored contiguously. Okay. So I hope it is clear why array, at least till here. So because this is going to focus upon data data structures and algorithm, so I'm not covering all the aspects, but the most basic ones, which is mostly asked in the interviews. Okay. More theory, you can read it later on your own. Okay. So now let's look at the array declaration and initialization. So there are multiple ways. So here, if I just write this integer data type, if you write this, it shows that you are declaring an array of data type integer. Then if you write numbers, so it gives a variable name, okay, for the array, numbers. But this will just do nothing. It will just declare, means create a variable of array of type integers, nothing else. Because if you want to store something, you need some memory or space allocation, correct? Space in memory. You need to put items. Okay, but with this, you're just declaring. So you need to initialize, allocate as well. So how do you allocate? After this, if you follow this, then though you have declared, but at the same time you are allocating also. How do you allocate space? This is the new keyword. New keywords allocates space in the memory. In memory. How much space? Then here you are telling that five items space, but what is the type of those items? Because the size is defined according to data type. So those items are of type integer. So five integers means 5 into 4 equals to 20 bytes would be allocated. Okay, this is one way. Now the allocation is done, but nothing has been put there. So we'll talk about it later in the next slide. Don't worry. Let's see the next method. Next method is direct initialization. Means though we are declaring, but instead of directly putting, just telling that allocate me some space, I will put items later. Instead, I'm putting items directly. Okay, so this does the whole job. You don't need to write the new keyword. This way, you can directly create an array of scores having items 95, 87, 92, 78, and 88. Okay, this is how it is created then. And the third method is doing everything step by step. First, a declaration, then allocation, and then initialization. Okay, don't worry. I am not just intending to show you on this page. I will be coding it as well. But let's gather some more data and then we'll code directly. Okay, don't worry. So I hope this is clear till here. Different ways of creating arrays. How do we create array? I have shown integer type, but similarly you can create other type of arrays as well as strings, characters, boolean. Okay, no issues. Next is visualization. Okay, so memory visualization. But before that, as I told you earlier, here, okay, it will allocate space in memory. So five integers means 5 times 4 is 20 bytes. Though it is allocated, but once allocated, what is kept there? If you are not putting this, then what is there? Here we will answer that. Once this line is executed, what is filled then? What is filled in the allocated space? So Java put some default values. What are those values? That depend upon the data type of the array. Okay. So if it is integer, it will put zeros. Okay. So here it is an integer array of size 3. So initially when we are putting not any items, so it will be 0, it will be 0, it will be 0. Okay. If it were double, so it will be 0, 0.0. If it was boolean, it would be false. It was objects, then it would be null. Okay. So I hope it is clear. What are the default values? Now let's talk about the memory. Okay. Though you can see here some memory addresses written 100, sorry, 1000 to 1003, 1004 to 1007. What are these? Okay. So let's say, as I told you earlier, memory is linear. Okay. I have created an array of size 3. So contiguous allocation of memory of space in the memory would be happening. So three items, okay, correct? Three items, 1, 2, and 3. How a memory address is shown? Okay, I'm not going to talk about the exact physical address, instead, the symbolic. So let's say the every byte is given some address. So here for my array, this address is starting with 1000. This is called as base address. Okay, जहाँ से start हो रहा है, because in memory there are multiple addresses, but for your array, this is the start address. That's why it is called as base address. There are three items, but every item takes 4 bytes. So let's say first item, how much space would it take? The first item, 4 bytes. If I'm starting from 1000, 1000 is representing 1 byte, address as 1 byte. 1001 again 1 byte, 1002 again 1 byte, 1003 again 1 byte. So for the first item, how much bytes? 4 bytes. And what are the addresses that are covered by 4 bytes? 1000 till 1003. So for the base address of first item will be 1000. Okay, it will go till 1003. So similarly for next item, second item, what will be the starting address? Obviously, if first item ended at 1003, so second item would be starting at 1004. Again 1 byte. So this would be 1004. That's what is it here. 1000 to 1003, 1004 to 1007, and so on. 1008 to 1011. Similarly, this would be starting at 1008. Okay. So if someone asks for an array of size 4, how much space is it going to take in the memory? So 4 into 4 would become 16 bytes. Okay. If size is 4. Okay. I hope this is clear now. The memory thing. Now let's have a memory challenge. What is that? Now that you have just learned it very quickly, I have one more data type, double. Okay. This shows this is an array with a variable name is data, using a new keyword to allocate memory space in the memory of size what? 2 of type double. So if the starting address is 500, then what are the addresses for data 0 and data 1? Okay, and each double type variable takes 8 bytes. So obviously, if data 0 takes 8 bytes, है ना? 1 byte, 1 byte, 1 byte, 1 byte, 1 byte, 1 byte. How much? 1, 2, 3, 4, 5, 6, 1 byte, 8 byte. And if the starting address was 5000, so ending address would be 1, 2, 3, 4, 5, 6, and 7. This would be 5007. So obviously for data 2, what is going to happen? For data 2, I mean data index 1, it would be 5008 से start हो जाएगा till 5016. Okay, 15 actually. So the answer would be 5000, and for this 5008. Okay, this would be the answer. Next, to move to the array traversal. How do we traverse array? So for this 1D array, how do we traverse? Arrays are traversed using their indexes, because though they are collection of the same data, but we don't directly have the access to their base addresses. Instead, that compiler knows later. Okay, instead we know we can access them item by item. Okay, item by item, one after another, one after another, or direct at the index, because This indexing gives predictive address. आप निकाल सकते हो क्यों? कि compiler knows what is the base address plus index multiplied by size of integer here. So let's say base address was 5000. So I want the address of which item? 0, 1, 2, 3, and 4. Third item. So I'll do what? 3 multiplied by third index item, okay? Multiplied by size of integer is 4. So the starting address would become 5000 plus 12. It will be 5012. Let's say 5000, 5004, third one 5008, this one 5012. Okay, this is correct. So that's how compiler works. Okay, though we write with index, but it directly translates into the memory address later, and that's why arrays are faster in accessing the items as well. They don't need to start from here, then go here, 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 always. No. If you know the index of the item, you can directly access it. No issues. Okay, and it will be fastest. So here it is. Now, how to traverse? For traversing, you need to go one by one because you need to traverse all the items, not just a particular index to the item. Instead, you want to traverse a whole array. So to traverse whole array, you would be needing a loop to go over the array iteratively, every item iteratively. So loop needs to be stopped somewhere. So number of items is equal to number of times the loop is gonna run. Okay, so how many items? To know the items, you can just directly put this function to work. In Java, you can directly do this. Marks is the array name, so marks.length will return you the size of the array, which is 5 here. Okay, length of the, sorry, length of the array, which is 5 here. Okay, now to traverse all the items, how it is gonna happen? Let's see here, 85, 92, 78, 90, and 88. So let's see. This zeroth index, first, second, third, and fourth index. Okay. Now, though I have written here the for loop, don't worry, I will show you show the whole code running also. Okay. So if I take in the iteration I equals to 0, okay, first iteration, I is less than marks dot length. You need to focus here what I have written here completely. Less than marks dot length. What is marks dot length? 0 is less than 5. Yes, it is true. If it is true, then come downwards. This executes at the very end. Once the user, there is no more thing to execute, then this will be executed, not just after this. Okay. So too many people confused with that. Don't get confused here. Okay. System.out.println does nothing but print the item and move to the next line. Okay. So marks at index I. So we will be simply putting the item which is at 0th index. 85 would be printed. Okay. Next. So there's nothing more to execute. So this I plus plus means I would be incremented to 1. Now it will reiterate. Initialization was done. So now the loop will be running from here. I less than max dot length. What is I? 1. 1 is less than 5? Yes, it is. So come downwards and print what? Item at index 1 in the marks array. What is at index 1? ये हो गया था. Now we are here. 92. Okay. After that, nothing to execute. So increment. So this I will become what? I equals to 2, 2 less than 5. Okay, here it is, and then 78 will be printed. Then I will move forward. I will become 3. So what is 3? 3 is less than 5. Yes, still. So here 90. I will print 90. Move forward. I will become what? The value of I will become. I don't know why my pen is working in this. Behaving this way, but I hope it is clear, right? I equals to 4, 4 less than 5, true. So 88 would be printed. This will be here. After that, I will increment it again. And this time, the value of I will become what? अब क्या हो जाएगा? I is equals to 5. Is 5 less than 5? No, because I is pointing here. So it will terminate. The loop will terminate completely. Okay. Once it is terminated, Till then, you have got all the items 85, 92, 78, 90, and 88. That's how you traverse the whole array. Okay. There's one more than I have written. If you want to change any item, you can directly access by and do it by index. Okay. Like at the second index, I can put 95. So later it will become 95. Okay. That's how it's done. So one D array also is done. Now let's see how 2D array works. Okay. Because for some data, 1D array structures might not be very suitable. Okay, so somewhere you need 2D data. Like, for example, I can say you must have known about some booking, correct? How many of you book tickets from PVR or Book My Show? Anyway, okay. So you must have seen some sitting arrangement. Seats are there. So how do they pinpoint the seats in their system? For human, by watching it, anyone can just say यहाँ से यहाँ जाओ. Even if you go in the cinema hall, you will see the numberings. What are the numberings? Every row is given alphabets A, B, C, something, something, and every column have given integers, digits, something like 1, 2, 3. So let's say this is row A from the screen. This is row B, this is row C, and this is seat number 1, this is seat number 2, 3, 4, and 5. Now you can see, you can represent this particular data for booking tickets, okay, for the seats in this grid form only. There is no other way, at least in the visual basis. Because in this arrangement, if you want to pinpoint a seat, how can you pinpoint? Can you just say seat number 3? There are 3 seat numbers. Three seat number threes. Or if you say seat number two, which seat number two? Because there are 3 seat number twos, 3 seat number ones. So you would have to say seat number one of row A. So this will called as A1. This is called as A3. Okay. So this is like a grid. So grid is nothing but 2D array. What is 2D array? Collection of 1D arrays. Yes or no? Like from here you can see every row is a collection of array having having 5 items. Yes or no? Every row in the cinema hall have the same number of seats. Correct? So these number of seats can be termed as one array, and 3 such arrays would be termed as a 2D array. Collection of 3 such arrays would be termed as 2D array. Okay. So how do we, I mean, create these? So obviously, you need to be sure about the size of this grid or size of this 2D array. Like 3 rows and 5 seats. Similarly, I have taken 3 rows and 4 columns. We can call it a matrix also. Whatever name you want to call, doesn't matter. Matrix आप अपना नाम भी लिख सकते हो, कोई दिक्कत नहीं. Okay, so no issues. But again, because earlier we were declaring int and this was sign of array. That was 1D array. For 2D, you will be writing int and 2 times this bracket. This will show 2D array. Next, what do we do? Name. Name is matrix, means a variable name. Then this is just a declaration. Then allocate memory. How to allocate? Keep this new keyword. This is allocate memory. But how much memory? Then and of what type? So it is going to be integer. So integer type. How much memory? For 3 rows and 4 columns. Okay. So in 3 rows and 4 columns, how many items are there? 3 into 4 equals to 12 items. And because it is integer, so how much space they are going to take? 12 into 4 bytes is equals to 48 bytes. This is the space they are going to take. Okay. That's how you do this. So here we did what? Declaration and allocation. Next we are doing initialization, means putting the items there. So int scores, you can just put it matrix also because this was not declared. So int matrix, the items, and the size is also 3 by 3. Okay, the size is 3 by 3. यहाँ पे 3 by 3 का है. You can put extra items for this. If I were to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, array, and this is how it would be looking for this particular matrix. Okay, this particular file. You can put items like this. Okay, I hope this is clear till now how a 2D array works. Now 2D array memory. So again, for every array, things are gonna be stored in a contiguous fashion. Okay, as you can see here. So row 1 is nothing but an array of size 3. Okay, so first item, second item, third item. You can see the addresses. 1000 is the base address. So 1000 to 1003, 1004 to 1007, 1008 to 1011. Next, next comes what? Because in the memory, as I told you, arrays are stored in contiguous fashion. एक के बाद एक ही store होता है. Okay, so first three items are stored here. This is 1000 address. Okay, this is 1004, 1008. Now this address is particularly 1012. 1012 से क्या start है? Next row. 1012 to 415, 1016 to 19, 122, 123. So next three items would be here. Row 0, row 1. Okay, that's how things work. 1016, 1020. Okay, that's how this is gonna look in the memory. This is the way. So how things get pinpointed, how compiler actually calculates the address here into the array. Into the array, again, corrective address होता है. That's why items are quickly accessed. Okay, how the address is calculated then? So it would be address is equals to base plus base plus this is the row size, this is the column size, correct? But these are the indexes. Okay, 0, 1 is I for row index and J for column index. So what will be doing? The formula will become I multiplied by total number of columns plus J column index. Completely these will be multiplied by 4. Let's check if this is going to work or not. So let's say the base address is 1000, right? And let's test for address at index 1 comma 2. Okay, base address is 1000 plus I is 1, so 1. Total number of columns are how much? How many? 3 plus J is 2 multiplied by 4. This will become 1000 plus 3 multiplied by 1, 3. J की वैल्यू क्या थी? 2 थी. ठीक है, 3 plus 2 5 into 4, 1000 plus 20. What will it become? 1000. This will become 1020. And as you can see, 1 comma 2 is starting where? This is 1 comma 2. At 1020 it is starting. Okay, that's how the addresses get translated. So I hope this is clear how the memory works with the 2D array also and how we created it. Now about how we can traverse them. Okay, so before showing you this code, first let's quickly go to the part where we will be directly writing the code to traverse the 1D array. Okay, here it is. So we have taken a 1D array of size how much? 7, 5, 3, 7, 9, 2, and 6. Though we are going to print the items, but what to do before printing? To print, we'll be traversing the whole array for please don't mind the predictions. I'm doing it in VS Code. That's a string. But I would suggest you to do it in a way that there are no predictions, so the suggestions, so that you can write it on your own. Okay. I will be initializing the I index to 0. I should be less than array dot length, then I plus plus, and then here. Because it was a 2D array, so I just need to do this system.print.out, system.out.println array, and then index I. Okay, this is how it will be printed. So let's see how this works. So Java C array is one.java. It got compiled, and here you can see one more file has been created. Okay, and then running it. Array elements are, yeah, array elements system.out.print. Can anyone tell me what is wrong here? System dot sorry system.out.println. Oh, I think I didn't save it. That's why. Let's compile it again after saving, and yeah, here we got the answer 5 3. So please don't forget to save your code once you have made any changes. Okay, this is how it works. So now 5 3 7 1 9 2 6, we are getting things printed. Similarly, let's have a look at this 2D array. Okay, let's try to print this. So here I have put the items already. So how to print this into the array, and again let's take this for int I is equals to 0. I should be less than grade dot length I plus plus. Okay, then here. So this was to access the rows. Now let's do it for the column. Okay, and j is equals to, okay, here I think it got mistyped. Yeah, now j is equals to, again for column starting with 0th index, j should be less than grid dot length would have given number of rows. Now column कैसे मिलेगा? Let's see. Okay, let's say this is some grid. Okay, this is a 2D array. 2D is nothing but collection of 1D arrays, correct? So this is 0, so this is first row. So if the name is array, then array dot length gives you number of rows or items. Okay, but every row have 1D array itself, correct? So how to get that size? So let's say यहाँ पे आपके कितने items थे? 1 2 3 4 1 2 3 4 5 1 2 3 4 5. Okay, so 0 1 2 3 and 4. So what I will do, I will take array, then what, put first row, any row you can take, then do dot length. This will give you what? Length of items in first row. Okay, so this is exactly what we're going to do to get the size of columns. So here what we're going to write is grid, then 0 dot length. Okay, I should be less than, yeah, then I plus plus. Okay, and then I'll be doing one more thing. What? Simply putting the system.out.println, so that every item would be printed next line. Okay, same line also we can print, but no issues. Let's put it in the same line. Okay, grid I comma j plus one space is what we are putting here. So now let me save this and compile and run this. Okay, Java C arrays, sorry, 3 is the file name, 3.java, and let's run this. Okay, what is happening here? Let's see. So exception in the thread means something index out of bound. Why is it index out of bound? What do you think? What is happening here? Why is it index out of bound thing is happening here? I think the issue lies here is we are doing j equals to 0, j equals to grid I dot length, and then here j plus plus should be there. That's why we're getting the errors. Okay, index out of bound. And I think we just need to do one more system dot out dot println to avoid some printing issues, okay? Because once this is done, we would be just changing the line, okay? So now let's see how this is gonna work, okay? Okay, I think I did it twice. Yeah. So 1 3 5 7 9 2 4 6 and 8. 1 3 5 7 9 2 4 6 and 8 is what it is gonna work with. Okay. So I hope this is clear. How you can traverse this now. Just do this problem. Given an array of integers and a target value, return the index where target first appears or minus one if not found. So how are you going to do this? What is going to be your approach? Take 2 seconds and then write your approach. Or take 10 seconds and write your approach in the comment. Okay. Meanwhile, let me write this for you as well. So first thing is because it is a 1D array, correct? 1D array. So what you can do is target value is given, 1D array is given, you need to return the index where the target first appears. Means you need to find if this item is present in the array or not. Otherwise, you can return minus one, and if it is there, then you can just return the index. Like here, you can see 8 is present here. So index would be 0, 1, 2, 3, and 4. So 2 would be returned in answer. Okay, that's our output is 2. Let's see the next option, next input. So here items are 4, 2, 8, 1, and 9. Index is 0, 1, 2, 3, and 4. Target is 5. But here we can clearly see 5 is not present here. So what is the output? Minus 1. Okay. But at the same time, this clearly shows you that you need to go to every item and check if it is 5, no. Go to next. If it is 5, no. Go to next. It is 5, no. Go to next. It is 5, no. Go to next. It is 5, no. Go to next, and you will come out of the array. So this is showing you what? Traversing array while checking for the target item, correct? So that's why we'll be writing the code like this, okay? Though we have, declared the array, we are passing it in the linear function, the array we have passed and the target we have passed, and here it is doing nothing but the same. That's why I'm not showing you the code again. Instead, I've written here. So it is traversing all the items of the array one by one, and while traversing, it is matching here. Okay, if the current item, which is array of I, equals to target, okay, then we are returning I directly. I is nothing but the index, and once the return statement runs, this whole thing would be terminated, and the control will be coming back here. Okay, so in the very first case, for the 8 target 8, this is return what? This is return 2. So 2 would be stored in this result. Okay, return 2. Then we are doing nothing but just simply putting found at index result, which is 2. Okay. I hope this is completely okay for you. And here, as you can see, how many items we are checking? 4, 2, 8, 1, and 9. We are checking all the items. So if the array is of size n, we are checking all n items. Okay. Why I'm saying so? I will show it later in the discussion of time and space complexity. Okay. And how much items of space we are taking extra. This space of array was already given in the input. Additionally, we are not taking any significant. If you are taking one or two variables, doesn't matter why, because n can be of size कितने का हो सकता है? N can be of the order of 10 power 9. And compared to 10 power 9, 1 or 2, even 10 or 100 is also nothing. Okay? So that's how it will treat it as constant space. And for the time taken by this is we are traversing all the n items, so it will take order of n time. Okay, and space order of 1. 1 means not just 1, it is to show constant space. Okay, that is how it is. Moving to the next part, complexity. That's what I was telling you. So if you find your first element at the very first index, okay, so the best case would be that, and that's what we have seen here on this page. If we find an item, we'll be returning. So if we are finding our item at the very first position, will directly return. So only one comparison would be done. That's why it will take constant time. Okay, one out of one. Worst case, all the items you are looking at, and if you're finding it either at the last item or item is not present. Anyway, traversed whole array. Okay, average case आपको middle में मिल जाता है. Okay, if you're checking n by 2 items, then that again n by 2 or to big of n by 2 because it shows the worst case, so it will be treated as n only. Okay, and space complexity because we have used few variables, it will be constant. Okay, constant. I hope this is clear. Similarly, we have the problem for 2D array. Again, same search is what you need to do. Search for target in a 2D array. 2D array is given and target is 9. 9 is present here, so we would be just printing found 1 1. Okay, and target 0 is not found, so we'll be just printing not found. Though I'm gonna show you the code, but I will really suggest you or urge request you to do this on your own as well. Okay, because again, as similar to the previous question, here also we need to traverse and check if the item is present. Though checking all the items is not very optimized, but that is for the later part when we'll be discussing another searching algorithms for the linear search. It is completely okay. So don't worry about optimizing it right now. Okay, that will just give you more burden. Okay, so right now just learn the basics. So here we have the array. Okay, we are passing it to the function where we can search it. Okay, great, and the target. So here we have received it in the matrix and the target as target. This is traversing the row, this is traversing the column, and for every pinpointed item in the I comma j, the comma column, we are checking if it is equal to target or not. If it is equal to, okay, then this if condition would be true, and we are returning with what? Found at I and j. Okay, that's what we are printing. If it is not, then again this whole for loop would be running. Both for loops would be running. And if we don't find the item, even after traversing all the items in the array, 2D array, then this would be terminated. And once it is terminated, once the termination is done, we will be coming to this line. This line will be executed with what? Return statement of returning not found a string. Okay. So in that case, not found would be printed here because system.out.println is working here. So in this case, what would be printed? None is where 0, 1, 2, 3, 4. Okay. So found at 0, 1, 2, 3, 4. Okay. So 1 comma. But again, it is not a linear, I mean 1D array. So 0, 1, 2, 0, 1 and 2. None is at 1 comma 1. So we will be getting it 1 comma 1. Okay. That would be the answer here. And if we are trying to search for 0, so not found would be printed. Why? Because 0 is not available here. And because we are traversing all the items, so how many items? N square items. If row equals to column equals to n. Okay. If row is equals to column equals to n. If row equals to n, column equals to m, then it will be number of traversals would be what? The number of traversals would be n by m. Okay. That's why our time complexity would become here big of n square or n by m. Okay. Space complexity again we are taking few variables only, nothing much compared to the size of the array. So that's why the space complexity would be constant here. Okay, I hope this is clear. Now after doing this, we have one more thing, one coding challenge. Though this code looks quite familiar to you because we have been working on this continuously, but at the same time there's some mistake here. I need to find out. Take 10 seconds and write in the chat what is wrong with this. Okay. Otherwise, anyways, I am going to tell you the answer. So this is the array initialization. Anyway, we are traversing, but what is written here? What does data.length gives? Data.length would give you 1, 2, 3, 4. 4. Okay. Your for loop is running from where to where? I would be 0, 1, 2, 3, till what? I is less than equals to greater dot length, which is 4. So 3 is less than 4, true है. 2 is less than 4, true है. 1 is less than 4, true है. 0 is less than 4, true है. ठीक है. But if it is true, then it will re-add it again, and I have become 4. Is 4 less than equal to 4? Actually, less than equal to था ना? Yes, it is less than equal to. So less than तो नहीं है, but it is equal to, so it will be true. If it is true, and I will come inside here, I will try to pin the item at the fourth index. But does the fourth index exist? Is it existing? No. So this will give you index out of bound exception. What to do to avoid this? We don't want to go to the fourth index to access any item. We want to stop at 3. So 4 is what? 4 is equal to 4, not less than. So remove this equal to. Okay? Remove this equal to. So that's why index out of bound would be the answer here. Okay? That's wrong with this. I hope this is clear to you. Let's move further. Our key takeaways. Key takeaways are what? Primitive versus non-primitive is what we have learned. Data types. Okay? Then array, memory model, and contiguous storage is what we have learned. 1D, 2D declaration traversals, linear search algorithms, and time and space complexity is what we have covered. These were the basics about array. Basics of array. Okay, is what we have worked upon. Now, what are we gonna learn in the next session? So tomorrow we'll be covering the problem solving techniques. As days, let me tell you what this is all about. It's not about mugging up each and everything. Yeah? The more you remember doesn't guarantee you to that you will be able to solve the new problem also. Instead, these the concept we have learned today are more like foundation block. Okay, you have learned it. That is completed. The foundation is done. Now you need to move on to find and work on the patterns of questions that are asked. Once you have covered the patterns, you'll be able to create your own thought process of problem solving. Then only you will be able to solve any new problem that comes in the interview. Okay, because mugging up is not a solution. That doesn't guarantee anything. So that's why we will see new pattern problems. Tomorrow, the pattern of question we are going to discuss is two pointer. I will be showing you multiple ways to solve those kind of questions. So we'll be seeing reverse an array in place, check palindromes efficiently, and why this pattern is game changer. In 70% of interviews, this is always asked. Questions on 2 pointers. 70 to 80% of interviews, questions on 2 pointers are always asked. Okay. Now your homework would be practice today's code examples. Try to find maximum element in an array. Count occurrences of a particular value. Okay. These two questions you can try in particular. That's what I will recommend. So then, thank you everyone. That's all for today. Let's meet in the next session.